Okay, so here's what we're going to do first. We're going to talk about inverse functions that you did back in Algebra 2. Now, this is one of those things where I need to go through the basics of this, just review the basics. And if you remember it or not, as long as you remember how to apply this to the trigonometry, that's all that really matters. So issue 1. Let's say we had a good old function like f of x equals x cubed. So you've been doing this for a long time. So good old f of x equals x cubed. So you know you've got point 1 comma 1 right there would be on the graph. And then point -1 comma -1 would be on the graph right there. All right, so what you would do last year in Algebra 2 is you'd say, okay, I need to make a inverse function. So instead of f of x, we're going to call that y. So we're going to say y is equal to x cubed. And then remember how you swap x and y? You swap x and y. So therefore you would have x is equal to y cubed, but then you solve for y. So you'd end up with y is equal to the cube root of x. And then you say, okay, y is equal to the cube root of x. Oh, that's real easy because that's the curve that looks like this. So there's your two functions. You've got f of x, and then you've got f. Remember the old f inverse to the -1 power. I know -1 power on our calculator means inverse, even though you're used to thinking that means reciprocal. So I know how that goes. But anyway, then think about this. You're swapping x and y. So remember that good old, oh yeah, if you're swapping x and y, that means that the inverse graph is a reflection. So it reflects over the good old y equals x line because you're just swapping x and y, so it should reflect. So assuming this is a perfect graphs, that it reflect over the good old y equals x line. You're saying, okay, that's no big deal. We can run around doing that. Inverses were okay, they weren't. Inverses were easy back when we did these. All right, here's going to be the problem. Right now, this one was a simple example. That's why I chose it, because the original function, x cubed, it is a function, passes the vertical line test. And when we did its inverse, the inverse function also passes the vertical line test. So if the inverse passes the vertical line test, you know what? Should have done here? Should have said, well, the domain is all real. The range is all real. And remember, if we're swapping x and y, that means we're also swapping the domain and range. Should have brought that up earlier. I've got that on the next thing we have to do. So we're swapping the domain and range. So we're swapping x and y. So we're also swapping the domain and range. Okay, anyway, what I was trying to get to is this one worked out nice and neat because when we did the inverse already was a function. And in fact, last year, you would say if the inverse is not a function, you would call it a relation. So inverse, it has to be a function. If it's not a function, it would be a relation. But what happened was we said, oh, well, the original function also passes the horizontal line test. It also passes the horizontal line test. Therefore, its inverse, therefore the inverse is a function, in which I know I just corrected myself and said, if we say inverse, it's automatically supposed to be a function. All right. So if a function passes the horizontal line test, if a function passes the horizontal line test, if a function passes the horizontal line test and the vertical line test, because it's a function, we call it a 1-to-1 function. So if it passes the horizontal and vertical line test, we call it a 1-to-1 function. Okay, so this is what you did last year. You swap the x and the y, solve for x, or solve for y, and then you had your inverse. Well, unfortunately, something came up last year. And what came up was this. You said, wait a second. What about x squared? If I graph x squared, I get this curve right here, good old parabola, which would make a bunch of values right here. And you're saying, so the domain of my parabola is negative infinity, left to right, negative infinity, positive infinity, and the range is 0 to infinity, including 0. Well, the problem here is then when we swap the x and the y, here's our original function, f of x equals x squared, which is the same as y equals x squared. So we swap the x and the y, just like we did earlier. We swap x and y. And then solve for y, though. When we take the square root, we're supposed to do plus or minus, and plus or minus x. If we graph plus or minus the square root of x, we get this guy right here, which is not a function. So somebody says, oh man, since we're obsessed with everything being functions, here's what we have to do. You go back and look at the original function and say, wait a second, the original function is not 1-to-1. Original function is not 1-to-1. So remember what we did? We restricted the original function to be 1-to-1. And usually, most of the time we did that, because we only did really basic examples when we did this in Algebra 2. And I hadn't taught in Algebra 2 in a few years, but we did this. What we would do is just go through and say, all right, I'm going to restrict this so it's 1-to-1, because right now it doesn't pass the horizontal line test. So what we would always do is we would just go through and erase the left side. So if I erase the left side corresponds to the bottom of the inverse. So if I'm erasing the bottom part, this is what I have left. So I'm essentially cutting off the bottom here. So I'm changing. How about this? Originally, when I did my original function here, the domain was 0 to infinity because we just swapped the domain and the range. And the range was all real numbers because it's going up and down. It's going up forever. It's going down forever. So the range is all real numbers. But when I erase that, see, my range becomes the new domain and my domain becomes the new range. But when we restrict it, so when we restrict it like this, we cut off the bottom part. So we restricted the range. We cut off the bottom part. So that made my new range this, which if you go back to when you did this in Algebra 2, you said, okay, we got to restrict this. So we called this the restricted domain. So when I erased the left side, my restricted domain became 0 to infinity. I just did that the wrong way. The restricted domain right there becomes my new range. Okay, see, that was my original range, but we had to restrict it. Okay. So the whole point of this is we're going to have to do this with our trig functions. We're going to have to restrict them so that we can find their inverse. I'm never going to ask you this. I'm never going to ask you this again. It's going to come up later in your math lives, but I just wanted to go through it as a review that this is something that affects what we're about to do. So we'll move on to the trig functions next. So this is just a general review.